Today, let us dive into the certain other details about the functions such as recursive functions, anonymous functions, or we call it as a lambda functions. So what are these functions actually? So recursive function is a function which calls to itself. So in real time scenarios, wherever certain problems which exhibit the behavior of divide and conquer strategy and also the property of backtracking, in such scenarios, the usage of recursive functions will be bit easy rather than the using the iterative approach. Every problem that is addressed using an iterative approach can be also resolved using the recursive functions. But certain problems like towers of Hanai problem, which can be solved easily with the help of the recursion rather than writing an iterative approach. So one has to know how the recursive function will work, how the recursive calls are really managed in the computer memory. And then we will look at these anonymous functions or lambda functions. Lambda functions are special functions which are defined using the keyword lambda. And in fact, the advantage of lambda function is when we define a normal function, there is a overhead associated with the jumping of function, the execution flow from function call to function definition. And after finishing the function definition, the control should come back from to the place where it is left off initially. So it consumes some time. In case of lambda functions, which really works like inline function, where the function that is defined using the lambda keyword, so in fact that is replaced with an expression. So that way it will reduces the some time that is associated with the function call and also function definition. So let us see the more details about this. So initially we will work on, let me stop this video. Yeah, on recursive functions. Recursive functions are a type of function in programming that calls to itself. So they are commonly used in situations where problem can be divided into smaller, similar subproblems I was telling you. And whenever you are using a recursive function, the programmer has to be careful enough in handling the recursion. So because otherwise the recursion will take you to the infinite loop. So every recursive approach will have to handle the two conditions. One is base case of the recursion, where this base case will stop the process of recursion because the function is calling to itself. How many number of times you call, there must be a scenario where you meet some certain set of condition where you stop calling the function. That is called the stop criteria, which also we call it as a base case. And also then recursive case. In recursive case, the function calls to itself with a modified set of values in the function parameters. Then that is used to at least solve the actual original problem in a stepwise manner. So each recursive call should ideally reduce the problem size or the complexity of the problem. Let us look at this small example. So I have taken a small example program where we try to calculate the factorial of a given number. So I am defining the factorial function. You can see. So just read the n value from the keyboard, and then I am invoking the function. I want to calculate the factorial of a given number. So the function call will push the control to the function definition. And my base case is if n is equal to 0, means 0 factorial or 1 factorial, we know it is 1. So then I stop my recursive approach. So this will return 1. Or else what I will do is I will repeat my recursion, but see, instead of calculating the n factorial, I will be calculating the n minus 1 factorial. So that way we are moving closer to the solution of the given problem. So how this actually will work out? Let us see. So initially I am calling fact. Imagine that I am calling the fact of 5. So if you look at the definition, it becomes the 5 star fact of 4. And the fact of 4 will be replaced again with 4 star fact of 3. And then this fact of 3 is replaced with 3 star fact of 2. So the recursion goes on, and this fact of 2 will be replaced with the 2 star fact of 1. So this fact of 1, because n becomes 1, it is replaced with 1 where the recursion stops. So the value goes back to the previous step. Then fact of 2 is replaced with, in fact, this is with the 2 star 1. And the fact of 3 will be replaced with, this will be replaced with, in fact, 3 star 2 star 1. And this fact, and the fact of 4 is replaced with 4 star 3 star 2 star 1. So we use this backtracking approach. In fact, the recursive calls will be managed by the operating system using a stack. Initially, we push the fact of 5, the return value, into the stack where should the control should come back. The return value and the function name will be pushed in. Then fact of 4 will be pushed. Then fact of 3, it goes on, the stack goes on in the upward direction. Then fact of 2, then we will come to fact of 1. So the return value of fact of 1 will come to the definition of fact of 2, yes, and the return value of fact of 2 will come to the definition of fact of 3, and the return value of fact of 3 will come to the definition of fact of 4, and the return value will come to the definition of the fact of 5. In fact, in the fact of 5, we have written 5 star fact of 4. So this will be replaced. So the recursive calls will be pushed into the stack. So this is a stack, is a data structure which allows the user to insert and delete the data items from the single end. So it is also called as first in first out data structure. So recursive calls are managed using the concept of stack. So this is how the recursion will work out. But unfortunately, if you're really, for example, someone else incidentally, if you write like this, say fact of some x, you are defining, okay, is equal to, see, for example, you want to calculate the factorial. So is equal to, say, if you write x star fact of x minus 1. So if you write like this, what happens? This becomes, the recursion becomes infinite. Unfortunately, it will give you a runtime error because you will be pushing the infinity number of function calls into the stack. The whole memory, the stack memory is not fit enough to accommodate all these function calls. So one has to be very careful about the recursion. So we solve many problems using the concept of recursion. The classical problems like Fibonacci series, GCD of given two numbers, Anai-Towers problem, a factorial of a given number, sum of the n natural numbers. So all these are the classical problems related to the recursion. So we will talk about the one more problem that is called Fibonacci series. What is Fibonacci series? In fact, it is a series in which first two terms are 0, 1, and the third term onwards will be found as sum of the preceded two terms. That is 0 plus 1 is 1, then 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5. That's what this is the series. So you may be asked to write a program that will print the first n terms of Fibonacci series. N terms of Fibonacci series. So how do you do that using the recursion? So in case of recursion, you need to find out the recursive equation. For example, see. So I will define this Fibonacci series as f of n, and you can leave the logic for 0, 1 because f of 0 and f of 1 are 1. So the third term onwards, it is simply sum of the, I will write a recursive equation, f of n minus 1 plus f of n minus 2. What is the base case? The base case is f of 0 is equal to, say, 0, and then f of 1 is equal to 1. So these are the base cases which will stop the recursion, and otherwise the recursive approach will be using this logic to solve the given problem. So I want to print n terms in the Fibonacci series. How do I do that? So I need to make out what is the Fibonacci value of the fib of 0, and what is the Fibonacci value of fib of 1, then fib of 2, so on. If I want to print the n terms, so how many n terms I want to print? So I am supposed to call n times the fib function using the recursive approach, where each function will be calculating the value at the required at the specified position in the given series. So we will see how this program can be written at my idle. Let us see. I want to calculate the Fibonacci series. So let me define a function. Yes. You can. Okay. Let me define the function as fib. So which will take the parameters, say, n. So what is that logic? Is the base case is if n is equal to, I say, if n is equal to 0 or n is equal to 1. So what has to be done? You have to stop the recursion, means you know the position value that is written n. If it is 0, yes, I'm sorry, if it is 0, it is 0 because first two terms are constant, first two terms are 0, n. So or else what need to be done? So you have to return, what is that? The recursion has to be used here. So the recursive equation is fib of n minus 1 plus fib of n minus 2, right? So that's what the recursive approach. So because it is sum of the third term onwards, it is simply sum of the preceded two terms. I hope you are getting me. Yeah. Then, so how do I call this? How do I pass this value? Yes, you can get the input. Yeah, I want to get the input, say x or n, not an issue. So n is equal to simply, yeah, I want to get the input from the keyboard this time. So let me write, take my input, enter n value. Okay. So after getting the n value, what need to be done? So after receiving the n value, so let me place one more parenthesis. So I need to call the function, but the Fibonacci series, you need to invoke this function for every possible position. So I have to take a loop for I is equal to say 0, or I can say I in range 0 to n. So what need to be done? So you have to invoke this because it is returning a value. You can either invoke this function as a parameter in the print statement. Yeah, that's okay. You can also do that. So print, see, fib of I. So yes, so let me see this. Is it okay or any errors are there? We will see errors. Enter n value. So let me give. So I'm getting actually 10 values. More or less, you can fix the n value. It could be n minus 1 or n minus 2. That's no issue. But see, yeah, it is not in the form of series. So how do I get it in the form of series? Yes, you can see. Right, wait for a while. Let me close this window. Yeah. So instead of printing new line after every number, so what could be the separator? We can write in the printf. Yes. So some space. So better. So that will give you the look and feel of the Fibonacci series, right? Let me run it. Enter n value, say 10. So it's not coming. Yes, not separator, and we need to write the end. Also not the new line. I want to write. So however, the by default it will be printing one space, the print statement. Yes. So let me save it. Let me run it. So this time, so let us see. Yeah, you can see that. So how many actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm getting 10 values. So this is the way how the recursion will be working. So one has to be careful enough. But what is the advantage of recursion is, yeah, so it can improve the code readability because simply it will make you to write a very concise code. So with that, let me move on to the anonymous functions or lambda functions. These are the special functions which are defined using the keyword lambda. So almost they work like inline functions. If you are aware of C++, so in C++ we have inline function where the function call simply replaced with the function definition. The control will not jump from one place to another place. The place where the function is invoked, there itself it is replaced with the expression, and the expression will be evaluated, and the evaluated value will be written back to the place where the lambda function is being invoked. That is the beauty of the lambda function in Python programming. So you can see how it can be defined. So the syntax is that you use the keyword lambda and the arguments list or the means the variables, and what is the result to be what is the operation to be performed on the arguments list, and in fact the evaluated value will be returned back to the place where from function is called. So in fact the lambda functions will be used with map and filter comma reduce methods where the methods are expecting a function as an argument. We will be actually using the actual advantage of the lambda function. So but in the normal case you can see that, yeah, how do you call the when you call this function as sum. So initially what happens, where sum is defined, it will look at the name of the function, it goes to the name, and how it is not defined as a function because defined keyword is not there. Then it will find the lambda word, lambda keyword, then x will be incremented to x plus 1, and the value of 6 will be returned back. The value of 6 will be returned back. So that way you can look at this. So what are the advantages is, yeah, the advantage of this lambda function is you can experience when it is used with filter, map, and reduce methods. Okay. And one more thing is, if you define a function that returns a value, you need to write the return statement. But in case of lambda functions, the lambda function will automatically return the value from the place where it is defined. So let us look at the usage of this lambda function with respect to the filter, map, and reduce methods. The filter is normally used to filter the values from the given sequence based on some condition. For example, if I give the say I define the function as say some say yes, and the sequence is sum of the n natural numbers I want to give, sorry, sequence of natural numbers. Then what happens? I want to filter these numbers, only even numbers or odd numbers. So that way, how you can see without using this lambda function initially, how do we do that? Many number of lines of code is actually required. So I am using is even is a function. This is passed as a argument. So when it is used with the filter, iteratively filter works like iterative statement, and iteratively each element is passed here. Is even the each value from the list is taken is even of 0, and the return value and is even of 5. So that will be repeated for every list, and the return value, in fact, all these return values of these functions will be again back to a memory stream where the return value, if it is true, the actual value comes. If it is even, so the return value will be that number. So if it is 5, it is odd number. So obviously 0, 10, 20, 30 will be returned back to a memory stream, and that's what the filter method is doing. So this is a stream, so memory stream, and now I want to map this memory stream to a list, to a new list. So then my list variable will be pointing out this memory stream. Thereafter, I can able to access the elements in the memory stream in the form of a list that you can see. Okay. So that's what this is even method is now. Instead of going back to the function and coming again back to the place where the function is passed as an argument, you can just write a lambda function that is replaced with a simple expression. So when it is invoked, so it is replaced with a simple expression. Okay. So and the return the result also will be automatically returned back to the same place. So if it is dividing, the number is divided by 2, and the number is returned there. So that way it will reduces the lot of code over there. So the code becomes very concise. The readability of the code will be improved. So the same function can be also used with a map. So in case of filter, will be filtering the values. The map will be the mapping the given list of values. It will reduces the given list of values and maps to the sublist. Okay, there you can use any mathematical operation over there. So in fact, this list could be I mean to say it's not sublist actually. So you can apply an operation on every element of the list. So the output of this lambda function also will have the same number of list items, but they're modified, updated list items. What I'm doing is so I'm supplying every list item as a parameter to this function, lambda function. Then what it will be doing on the given parameter, it will doubles the value and it will return back into the memory stream where again the conversion happens. So we are converting that memory stream object to the list object. So there onwards you can access the elements in the form of a list. So same with the reduce method, but reduce is not a simple library function. You need to import function tools module. From function tools, we need to import all the modules. Because I have placed a star here, means all the modules and functions are imported from the function tools. Then what the function actually the reduce method will be doing is it is actually performing the aggregate operations using the lambda function. So what I'm doing is I'm supplying the list here, and the expression is being written is whatever the elements you are passing over there, that has all the elements has to be summed up. So that way it will return the aggregate value of the entire list. So aggregate value means sum of the list elements. So what is the Some here it is 150, you will get the 150. So lambda functions are more useful with respect to this filter map and reduce methods rather than using the lambda functions on their own. So I hope it is very clear. You can really want to go through further details. You can work on any of these references given here. So with this, I would like to conclude the sessions on functional programming in Python or functions in Python. If you have any queries, just feel free to contact me. Okay, thank you.